Hello guys. So in this video, we're gonna discuss Leetcode 301, remove invalid parentheses. So this is a coding question that can be asked in Facebook interviews as well. And yeah, let's get started. So for this question, we're gonna be given a string S that contains parentheses and letters. And we're gonna remove the minimum number of invalid parentheses to make it input string valid. So we need to return a list of unique strings that are all valid with a minimum number of removals. We can return the answer in any order. So for example, if the input string s is like this, then we can return the valid parentheses like the list below. So here we have an extra right parenthesis. So we just remove one extra right parenthesis. And no matter where we remove it, as long as the result is valid, we can just return it. And here, this is another example, and this example contains letters. So these are these two are the valid parentheses string, and then like for example 3, the output will be an empty string. So for this question, it's more like a backtrack problem because we need to exhaust all the possibilities that we can to remove the invalid parentheses so that we can find all the valid strings. So, however, to start with, we first need to find how many left parentheses and how many right parentheses we need to remove. For example, in the example one, right, it's obvious like we have one extra right parenthesis. So we all know like for this input string, in order to make it a valid output string, we have to remove one right parenthesis. And the same here, like example 3, we know like there is one, this right parenthesis is not valid, and this left one is not valid. So we need to remove one right parenthesis and one left parenthesis to make it a valid string. So which we just remove all of them. So okay, so for this problem, like the first step is to count how many left parentheses to remove and how many right parentheses to remove. Then we're gonna use backtrack algorithm to exhaust all the possibilities on removing the parentheses, which we're gonna try to remove the right and the left parentheses like to the number, the number like we calculated in the step 1, and then make it a valid string. So yeah, so let's get started. So the first step would be, let me just make it larger. So the first step is like we need to find the number of left and the right to remove. So, sorry, to remove. All right. So in order to find the number of left and the right to remove, we just loop through the string, and then we just check if the left one has any closing rights, or if the right one, like if there's like if there is a right parenthesis but there's nothing left, no left parenthesis on the left side. So let's just loop through it. So for char in S, if char equal to the left parenthesis, right? So if it is a left one, then we just we need to initialize the left count. So they are initialized to 0. So we know like we have like left equal to plus equal to 1. So we have like increment the left count. Otherwise, else, yeah, since we can have letters in the string, so just do else if check if it equals to right parenthesis. Then if it's the right parenthesis, so if there's no left, if not left, if there's no left on parenthesis, then this right one is invalid. So we just increment it by 1. So same, we need to initialize the right count. So if it's a right parenthesis, and then there's no left parenthesis on the left of this right parenthesis, then we know this right parenthesis is not valid. So we just increment by 1. Else, we just decrement the left, right? So we know like this left is closed by this right. So this left is closed by this current right. So we just decrement it by 1. All right. So now we can get all the invalid left and the right to remove. So these are the number of right parentheses and the left parentheses we need to remove. So now we need to define the helper function for the backtrack. So what kind of parameters we need to track? What parameters we need to track for the backtrack algorithm? So of course the index, right? So the index of the current string, like when we are iterating through a string, like the current index in the string, like we are iterating, right? And then we are removing like these number of left and the rights, right? So we need to also keep track how many left parentheses we remained to remove and how many right parentheses remained to remove. So we need to reach a state where we reach the end of the string and then there's 0 left remained to remove and 0 right remained to remove. And also we need to keep track of the array, which the array contains like the current elements in the result string. So this will be the, we use array because the array append will be order of 1. Or maybe we can use just say current string array. Yeah, more descriptive. So that's it. So we will solve it later on, and then we just call the helper function. Yeah, call the helper function with the initial state where we start with index 0, and then there's this many left parentheses to remove, and this many right parentheses to remove, and then it's like an empty array to start with, and we just return. So we need to also keep track of a return user set. So every time we find a valid result, we just append it to the add it to the result set. We just return the list. List set. List of the result set. All right. So this is how the skeleton of the algorithm is ready. So we just gonna need to fill in all the conditions in the backtrack algorithm. Okay, so first we need to define the exit condition, when to exit. So we will exit if the index equal to the length of the string, right? So this is the exit condition. So when the result is we know like the current string array in this state case, like it's valid. So of course when the left remain, if there's nothing left, if there's nothing remained for the left parentheses to delete, and nothing remained on the right. So both of them, like we have nothing remained to delete for the left parentheses and nothing remained to delete for the right parentheses, then we know like the current string, like the result will be valid. So we just add it. We just add it into the result. So we can just do this. Join. All right. So we just join it under them. So this is the valid condition. Otherwise, we just return. So for all the other cases, for when we reach the end of the string, it's an invalid result. So we just return and it here. Now we need to check if there are following conditions. So if the current index equal to left, then what are we gonna do? Right? There are following conditions we need to consider. If it's equal to the right, and then right parentheses, then what are we gonna do? And then the last else, this will be a letter, just a letter, right? So what are we gonna do? All right, so let's start from here. So if it's left parentheses, then what there are, if it's left, right? So we can choose two. There are two things we can do. One, treat it as a left to delete. So we can just delete it. Let me just update comment. We can just delete it if it's deleted. Delete it. Or second case we can do is add it into this, right? So when we can delete it, is when there is left remain, right? So this is left parent. If we can delete it, if it's larger than 0, then we can delete it. Then we can just delete it. So if we delete it, then we can just call increment the index, right? And then left remain will -1, and the right remain will remain unchanged. And then for this one, we can just call copy. The reason I call copy here because this is an object, right? So and if we modify, if we make changes to the object, it's a reference to the object. So if it changes in other places, it will it will be this object like will change it as well. So I'm just making a copy of it so that it's we will just make a copy of it so that it won't be a reference to the same object for different functions. And either delete it or we can just add it to the current string. So if we want to add it to the current array, then what we can do is we can increment the index, make it remain unchanged. That right remain will be unchanged, and then we just append it to the current array. So pay attention here, like I'm not using append, I'm using plus sign. So in Python, when we combine two arrays, like one array plus another array, to create a new array. So they are not referencing to the same object anymore. So this will be good. So it's creating a new copy of the array. It will be similar to like array append an item and then copy. It will be the same as like that. Now, if it's a right one, right, they are also the same. Either delete it or add it to the current string array. So when we can delete it, we can only delete it if its right remain is larger than 0. Then we can delete it. If it's larger than 0, then we increment the index. Right remain will be decremented by 1, and then copy it, right? And then or we can add it. Yep. So yeah. So here we have a condition. We can only add it if there are more lefts than rights. So if, for example, we can only add it like if it's like currently like this, then we can add the right? Otherwise, if it's like this, then we cannot add. This is not valid, right? This will be yes. This will be no. So yeah, so this means we're gonna also need to track how many left and how many rights we have. Okay, so yeah, so let me just add it here. Left count, right count. Yeah, so we also need to track these. So left count. So this will be let me just update. So if it's deleted, so right count, left count doesn't change, so it will remain the same. In this case, left count will be incremented by 1 because we are adding it to the array. So left count incremented by 1. Yeah, makes sense. So in this case, left and right remain unchanged because we are deleting it. Okay, so now here we can only do it if left count is larger than right count. Then we can add it to the array. And in this case, what we can do is index will increment by 1. Left count will remain unchanged. We are incrementing this left count, and these two remain unchanged, and then we just append it to the array, append the result to the array. Yes. Yeah, makes sense. And otherwise, if it's a letter, then we just append it, right? Because there's nothing else we need to do. So we just append it to the array. So it will be index incremented by 1. All these remain unchanged. And this will just plus the char. We just plus the char. Okay, so now here we just also need to update the initialization because initially we're going to have 0 left quotes and 0 right quotes. All right, so let's run and see how it goes. Yep, makes sense. It's all valid. So time and space complexity wise, usually for backtrack algorithm, it's all exponential. So I would say it will be 2 to the power of n for both time and space. Because we have a copy of the array here as well. So like that's why we have a 2 to the power of n for space. All right. So this is the end of the video, and I'm gonna see you guys in the next one.